Hey, Abigail and Ellie and Michelle. This is 7-1. We're going to start 7-1. We're not going to finish these notes because this is kind of an involved section. We've got lots of stuff to do. But I'm going to give you an example that just kind of like shows you what we're headed toward in section 7-1. So I'm going to say we have a sample of 17 students because that's how many are in here. And we're going to talk about the proportion of students that are over 5'10". Okay, so raise your hand if you're over 5'10". 5'10 or over. 5'10 or over. We have 1, 2, 3, 4...
Abigail. That's it.
And Abigail, right? Is Abigail over 5'10"? Yes, 5'10" or over, okay? But Ellie and Michelle are not, right? Okay? So we have 5 of you out of 17, okay? Yes? The proportion in this class, according to this sample, that's the important part. This sample is 5 out of 17 students are 5'10" or over, over 5'10", which is what percent? 5 out of 17. Does anybody have a calculator with you handy? 5 over 17. Do it. 29.4%. 29.4% are, according to this sample, 29.4% are 5'10" or taller. Yes? Okay, now what we're going to do is we want to use this to estimate a population. That's what this chapter is all, this section's all about. We're using this number to estimate a population. So is it fair for me to say that, I'm going to use this information to say that 29.4% of all seniors in BH are 5'10" or over? Is that a fair statement to say? Right, not all of you in here, but I'm using the sample of 17 of you to guesstimate that the average, that the number of people, the percentage of seniors that are over 5'10" is 29.4%, okay? But if I do your whole class, is it going to be exactly 29.4%? No. Probably not, right? Okay, because we've got like some tall ones in here, right? The people who are not in here maybe are a little shorter, right? I don't know who's not in here. Isaac, Aiden, they're a little bit shorter, right? Tegan is shorter, okay? Some of those, like we have the tall people in this room mainly, right? Like the tall ones, okay? So that percentage would probably be a little bit lower if we did your whole class, right? So what we're going to do instead is we are going to actually, according to our sample, it is this, we're going to give a range. Okay? Instead of saying exactly, using that number and saying exactly 29.4% of all the seniors are over 5'10", I would give a range and I would say between, let's say, 25% and 35% of seniors are over 5'10", okay? And then I cover all my bases that way. Does that make sense? I'm going to give a range of values rather than saying specifically 29.4% of all seniors in Blue Hill are over 5'10". That's probably not going to be accurate. That's accurate for my sample, but not for the entire population. So rather than doing that, I'm going to do better and say probably somewhere between 25 and 35% of all seniors are over 5'10". And that would give me, like that would be a true statement. Does that make sense? Okay. What we're going to be doing in this section is we're going to be coming up with the range, right? Okay? It's not fair for me to definitively say exactly 29.4% of the whole population because that's only true for my sample, right? This is only true for sample. Not for the entire population. Okay? It's only true for my sample, not the entire population. So rather than saying that, I'm going to give a range of values, and that's what we're going to be doing in this section is coming up with a range of values. Make sense? Maybe? All right? So there's that. Okay, that's what we're going to be heading toward. Let's go down and let's talk about some of the variables that they use. P hat. Write this off to the side over here. We call this guy P hat because he has a little hat on him. P hat, that's how you pronounce him. He is the sample proportion. Okay, so what number is he according to the example that I gave you up above? What number would P hat be?
29.
That would be the 29.4%. What is 17? N would have been 17, right? Does that make sense? N was 17, okay? So P hat was the number that I had, or the percentage that I had that were in a certain category, whatever, okay? Sample proportion, 29.4%. That's what P hat is, okay? The population proportion is just P. So this is the number that we would say P lives somewhere between 25% and 35%. That's what we're trying to establish. We're trying to figure out what P specifically is according to the population, not the sample, the population, okay? So we're trying to figure out what P is when we know what P hat is. Is this making sense at all? Kinda, okay? All right? And this little range of values that I've given you is called a confidence interval. It's an interval, it's a range of values. Okay, so your confidence interval is a range of values. Rather than saying exactly 29.4%, we're going to say somewhere between 25 and 35, right? Ish. Something like that. That's your range of values. That's called a confidence interval. They will ask you for a confidence interval. They're just asking you for that range of values. Okay, and that's what we have to calculate. Okay, we don't just make up these numbers, we calculate those. Okay. All right, so a confidence interval is a range of values used to estimate the true population proportion. Okay, good? Happy with that? Okay, there's some other things that we have to talk about, which is something called a critical value. Okay, and a critical value is always denoted with this little symbol right here. Do you know what he's called?
Fish.
He's a fish, but he is actually called alpha. Okay, we will talk about him like every day from here on out, alpha, because we have to know our critical value. Okay, alpha is our critical value. We call him, he looks like a fish. Okay, alpha is our critical value, okay? And there are three main critical values that we will use. Actually, really four, because one's not in this list. The other one is, we will sometimes use 0.20% or 0.20 as a critical value. Not as often. We will mainly use these three. But that's kind of how that works, okay? We will use those main critical values, and I will show you. We're going to write those critical values on your Z-score sheet, that laminated sheet. We're going to write these on that so that you have these accessible to you, okay? All right, so for now, just know that those are the main critical value numbers that we're going to use, okay? On the back side, this next problem, we're going to talk about what those things mean. Ready? Are we super confused? Clear as mud? Okay, let's go to the back. Next page, let's talk about what a critical value is. Now, they're doing critical value as Z of alpha over 2. So they're saying they want us to find a Z-score if my critical value, let's say, is 0.01, or let's say my critical value is 0.05, or let's say my critical value is 0.10, like 1%, 5%, 10%. Do you see how those work? Okay. And they're wanting us to find the Z. The Z is actually the critical value, okay, that corresponds to the alpha. So these are my significance levels. We want to find the Z associated with that. I'll show you. Just wait. Clear as mud. Here we go. The Z that goes along with those. Okay. I'm going to show you how one of these is calculated. And what I want to do, let's just do the first one. I'll show you how the first one is calculated. Okay, you ready? We're trying to find these, which are the Z's that correspond to a critical value of those. 1%, 5%, 10%. We're trying to find the Z value, okay? And these are the critical numbers, or the critical values. That's what these are. So when they ask for critical numbers, they're asking for the Z, okay? So 0.01, 0.05, 0.10. Here's what this means. Ready? I'm going to do my bell curve, and I'm just going to show you this top one. Okay, I'm just going to show you the top one, but the other ones apply as well. Okay, this is how those ones are calculated as well. So here's my bell curve. Ready? Good? Okay. And when it says a 0.01% or 0.01, that would be 1%. And that is meaning that 1% is making up these two areas. So we're talking about the 99% in the middle, right? Okay. And that 99% that's in the middle is going to make a range of values from here to here. That's like where my cutoff mark is, okay? And it's kind of like saying 99% of the people are going to fit between these two, right? We have to figure out 99% of the people fit between those two. Why 99%? Because my critical value is 0.01, and that's 1%. So 1% is on the outside, 99% is on the inside, okay? If I were to do the other ones, we're not going to do them all the way, but if I were to do the other ones, that would mean 5% would be here and here, whoop, 5%, and 10% would be here and here, right? Okay, so if 5% is there and there, what's in the middle? 95. This would be 95% of the people live there. How many people live in the middle of the third one? 90, not 80. 90. 90% of people live in the middle, right? So we're looking at that range of values. We are just trying to locate what the z-score is there and there, right? And if you guys did the bonus on the review for the last chapter, this is kind of similar to that bonus problem, okay? You're not going to be expected to do this on a test, but I'm going to show you how this works and where they get these numbers from so you don't just think I'm full of crap, right? Which happens from time to time, right? So we're going to find those z-values. And the way that this z-value works is we are looking at this, like if we're trying to find this z-value, we're trying to find from here on back, right? What percent would be from there on back if I'm looking at the right z-score? 99% is here in the middle. Yeah, 0.5% would be here and 0.5% would be here. So this would be 99.5%. Do we see how that works? We're going to figure out what that z-score is. 99.5%, okay? 99.5% as a decimal is 0.9950. Maddie's confused. She's furrowing her brow. She's thinking, okay? So we're trying to find this z-score right here where the 99% is, but we have to go from here on back, which is actually 0.9950. If I'm trying to find that z, I look up in my chart backwards. We're on the positive side. Okay, find me the number on the positive side that is closest to 0.9950. Oh, heavens. And it has a star. And the star says 2.575. That one has a star. It goes all the way down to the bottom. So this guy's z-score would be 2.575. Do you see that? Like it has a little star. It goes down to the bottom. 2.575. That's the z-score. What would this guy be then? On the left side? Negative 2.575. Okay, good. 2.575, negative 2.575. Okay, so do you see where they get this number from? A 0.01 or a 1%, meaning 99% is in the middle, is going to live between 2.575 and negative 2.575. That's a pretty wide range, right? So this is how this works. Negative 2.575 and positive 2.575. They are saying 99% of people have z-scores between those two, right? Okay, then we narrow the range just a little bit and we go from 1.96, negative 1.96 to a positive 1.96, and they say what percent of people live between those z-scores? What percent of people would live between negative 1.96 and positive 1.96? 95, right? Okay, and then we narrow that range just a little bit more, and what percent of people live between 1.645 and negative 1.645? Does that make sense? So they're just finding the z-scores that correspond to that, right? Okay, 90% of people are going to be between 1.645 and negative 1.645 for a z-score. Do you guys remember calculating your z-score for like your height and that stuff? Okay, that's where you live between. 90% of you will live between these two values. 99% will live between these two values. That's kind of how that works. Okay, you will never be expected to calculate those by yourself, like the z-scores, because we'll have them on this chart. Okay, we're going to write down these values on the chart. Some of them are already written there, but these are going to be the critical values when they give you an alpha of whatever. So if I say you have an alpha of 0.05, the number you're going to use for a critical value, 1.96. You just read it off the chart. Okay, but this is where it comes from, right? That's kind of how that works out. Okay, it's the z-score that corresponds to that range, right? That's it. Okay, good? Confusion? Okay. Add one more and add the 80th percentile, which should go up here at the top if you want to go in order, but I can't write it that small. And the 80th percentile, his number is going to be, let me check. It's like 1.28, I think, but don't quote me here. Hold on. I can't read my chart. So, yep, 1.28. Okay, so if you have an alpha that is 0.20, which means you're doing 80%, his critical value is 1.28. Okay, so add that to the list. We will very seldomly use that 80th percentile, but we're going to write him on our chart as well. Okay, are we confused? Clear as mud? Okay, so I'm just showing you where these critical values come from. So all you need to know, if you're really confused at this point, all you need to know is if they give you an alpha of this, your critical values are these, whichever ones correspond to that. If you're super confused, they will give you those alpha values. Those are the critical values that go with it. Yeah? Clear as mud? Not too bad, maybe. Okay? All right. Now, we're trying to find the range of values that, like, our heights live in between, okay? So we said that in our sample,